Dear students, welcome to session 9, the topic DIAC and UJT, which is part of Unit 1 on power semiconductor devices under the course Power Electronics for 5th semester Diploma in Electrical and Electronics Engineering. At the end of session 9, one will be able to explain the operation of DIAC and UJT, draw VI characteristics of DIAC and UJT, and list the applications of DIAC and UJT. DIAC. DIAC is a bidirectional diode. It is a two-terminal semiconductor device capable of blocking and conducting current in either direction. It consists of three layers of PNP or NPN with uniform doping in all the layers. The two terminals of DIAC are anode 1 A1 and anode 2 A2. Figure shows the structure and the symbol of the DIAC. Operation of DIAC. When a positive or a negative voltage is applied across the terminals of the DIAC, only a small leakage current flows through the device. During this period, the device is in non-conducting or blocking mode. As the applied voltage is increased, the leakage current continues to flow until the voltage reaches breakdown potential. At this point, avalanche breakdown of reverse biased junction occurs and the device exhibits the negative temperature characteristic. That is, the current through the device increases while the voltage across the device drops to a small value. To turn off the DIAC, the current through the device should be reduced below the holding value. VI characteristics of DIAC. The figure shows VI characteristics of DIAC. As seen from the figure, for a positive or negative voltage less than breakdown potential, a small leakage current flows through the device. Under such conditions, the DIAC blocks the flow of current and behaves like an open circuit. When the applied positive or negative voltage is equal to that of breakdown voltage, the avalanche breakdown of reverse biased junction occurs and the device exhibits the negative resistance characteristic. Now, the DIAC begins to conduct and the voltage across the DIAC drops to a small value while the current through the device increases to a large value. The DIAC now acts like a short circuit or a closed switch. The breakdown voltage of the DIAC usually varies between 20 to 40 volts. To turn off the device, the current should be reduced below the holding current value. Applications of DIAC. DIAC is mainly used for triggering the DIAC in adjustable phase control of AC power circuits, in light dimming applications, in heat control applications, in universal motor speed control applications. We will come to next topic, unijunction transistor, that is UJT. An unijunction transistor or UJT is a two-layer, three-terminal semiconductor switching device. The three terminals of UJT are emitter E, base 1 B1 and base 2 B2. The figure shows the basic structure and symbol of a UJT. It consists of an N-type silicon bar having two contacts on each end for the base terminals B1 and B2. The emitter is highly doped P-type material deposited between base 1 B1 and base 2 B2 regions. The P-type emitter is placed at a point closer to B2 than B1. The N-type silicon bar between bases B1 and B2 behaves like an ordinary resistance. The operation of UJT. The figure shows the equivalent circuit of an UJT. The resistance of the silicon bar is called the interbase resistance RBB. It has two resistances in series, namely RB2, the resistance between B2 and the emitter junction, RB1, resistance between B1 and the emitter junction. The PN junction in the emitter is represented by a diode D. The operation of the UJT can be explained from its equivalent circuit. There are three instances. The first one being with no applied voltage to the UJT, the interbase resistance is given by RB1 plus RB2. Second instance, if a voltage VBB is applied between the bases with emitter open, the voltage will divide across RB1 and RB2. Voltage across RB1, that is V1, is given by RB1 divided by RB1 plus RB2, the whole into VBB. V1 by VBB is equal to RB1 divided by RB1 plus RB2. The ratio V1 by VBB is called intrinsic standoff ratio and is represented by eta. The voltage V1 is equal to eta into VBB appearing across RB1 reverse biases the diode. Therefore, the emitter current is 0. In the third instance, now if a gradually increasing voltage is applied to the emitter, the diode will become forward biased. When input voltage exceeds peak point voltage Vp, which is given by Vp is equal to eta into VBB plus Vd, where Vd is the forward voltage drop across silicon diode, and that is almost equal to 0.7 volts. So now the UJT is said to be conducting. When the diode D starts conducting, holes are injected from P-type material to the N-type bar. These holes are swept down towards the terminal B1. This decreases the resistance between emitter and B1. indicated by variable resistance RB1, and hence decreases the voltage drop between emitter to B1. The emitter current now increases regeneratively until it is limited by the emitter power supply. Now, UJT is said to be conductive. VI characteristics of the UJT. VI characteristics of UJT is as shown in the figure. It is plotted by taking emitter voltage VE along y-axis and emitter current IE along x-axis. The UJT operates in the following three regions. First one, cutoff region. Second, negative resistance region. Third, saturation region. In cutoff region, when the voltage applied to the emitter VE is less than eta into VBB, the emitter B1 junction is reverse biased and the device is said to be in off state. A small reverse leakage current flows through the emitter. Second one, negative resistance region. As emitter voltage VE is further increased, the emitter current slightly increases until the peak point is reached. At peak point, VE is equal to VP is equal to eta into VBB plus VD, and the emitter B1 junction becomes forward biased. The emitter now begins to inject holes into base B1 region. This reduces the resistance RB1 and emitter voltage VE and increases the emitter current IE. This process continues until valley point is reached. Thus, between peak point and valley point, the device exhibits negative resistance characteristics. The third being saturation region. Beyond the valley point, an increase in IE is accompanied by increase in VE. This is called as saturation region. Applications of UJT. UJT is used as a relaxation oscillator to generate sawtooth waves, as a triggering device for ACR and DIAC, in timing circuits, in voltage sensing circuits, in phase control circuits. Summary of DIAC. DIAC is a bidirectional diode and conducts in both forward and reverse directions. Small leakage current flows in the blocking state. DIAC conducts when the applied voltage is equal to the breakover voltage. The breakover voltage of DIAC varies between 20 volts to 40 volts. The DIAC is turned off when the current is reduced below holding current value. The DIAC works as a switch, open switch in blocking state and closed switch in the conducting state. DIAC is mainly used for triggering the track in adjustable phase control of AC power circuit. Summary of UJT. A unijunction transistor, that is UJT, is a two-layer, three-terminal semiconductor switching device. The UJT conducts when input voltage exceeds peak point voltage VP, which is given by VP is equal to eta into VBB plus VD. The UJT operates in the following three regions. 1. Cutoff region. 2. Negative resistance region. 3. Saturation region. UJT is used as relaxation oscillator to generate sawtooth waves as a triggering device for SCR and DIAC in timing, voltage sensing, and in phase control circuits. Now is the time for assessment. Let us answer few multiple choice questions. Question number 1. A DIAC has dash PN junctions 4, 2, 3 or 1. The answer is 2 PN junctions. Second question. The device that does not have the gate terminal is 1. Triac, 2. FET, 3. SCR, 4. DIAC. The answer is 4. DIAC. Question number 3. A DIAC has dash semiconductor layers 1, 3, 2, 4 or 1. The answer being 3. Question number 4. The normal way to turn on a DIAC is by gate current, gate voltage, breakover voltage or threshold voltage. The answer is third one, breakover voltage. Question number 5. A DIAC is dash switch, an AC switch, a DC switch, a mechanical switch or an electrical switch. The answer is DIAC is an AC switch. Question number 6. In a UJT, the P-type emitter is dash doped, whether it is lightly doped, heavily doped, moderately doped, or equally doped. The answer is it is heavily doped. Question number 7. When the emitter terminal of a UJT is open, the resistance between the base terminal is generally high, low, extremely low or negligible. The answer is high. Question number 8. After peak point, the UJT operates in the dash region, cutoff region, saturation region, negative resistance region or positive resistance region. The answer is negative resistance region. Question number 9. When the temperature increases, the intrinsic standoff ratio increases, decreases, remains the same, becomes 0. The answer is remains the same. Question number 10. To turn on UJT, the forward bias on the emitter diode should be dash the peak point voltage, less than the peak point voltage, equal to, more than or slightly less than the peak point voltage. The answer is more than the peak point voltage. Thank you.